Hey guys, welcome. I'm so excited because in this video, we're going to look at how you can draw procedural shapes using shaders. Many of the shapes are configurable and you can use coroutines or tween libraries or even just animate the values smoothly over time. These shapes have literally infinite resolution, so you can scale them up as large as you want and they will never get pixelated. You can get really creative with the kinds of shapes you make since you have 3 different intersection options. They are perfect if you are like me and you really dislike drawing things for UI. And if you add smoothing to your intersection functions, you can get some really unique results and it's just super satisfying to play around with. You can do all of this using signed distance functions or SDFs. Ready? Let's go. So starting at the beginning, what is a signed distance function? SDFs are just a function that take a point and the function returns the distance between that point and the nearest surface. We're going to use a circle as an example because it is the simplest SDF shape that there is. The point in our shader would be represented by our UV, and the surface would be represented by our radius since we're drawing a circle. If the distance that the SDF function returns is negative, then our point is inside the circle. If it's 0, then it's hitting the surface. And if it's positive, then it's outside the circle. And knowing just this, we can already do a whole lot. It makes it really, really easy to create perfect outlines, and they're cool because they have the side effect of being rounded since that's how the distance from the center works. But if you don't like that, you can also just make an inline. You can cut a hole in the middle so you really only have the outline of a shape. You can offset things away from the shape really easily. And again, it becomes really easy to create unique shapes with just a few toggles and sliders once you can subtract one shape from another or merge 2 shapes together. So let's make a few shapes together so that this makes a little bit more sense. Now, I love shadergraph, but I do find that if you try to do too much with visual nodes, it just becomes unreadable and too confusing. So what we're going to do is create an HLSL file to hold our SDF functions. So let's open that up in File Explorer. If you are using Windows, make sure you're able to see file name extensions so that you can actually create the file properly. And we'll create an SDF functions.hLSL file. Again, make sure it's actually .hLSL, not .hLSL.txt. You'll know that you did it right if in Unity it shows up with shader include in brackets. So again, we enter a point and we'll enter our UV for that. And we want to be able to control the radius of our circle. And finally, if you're making functions to be used in shadergraph, you have to enter what you want to return as an out parameter. So we want our distance. And a circle is just the length of our point minus the radius. That's it. Now, in my mind, this is a perfect use case for UI, just pretending that we're making buttons or something. So let's create a new canvas shader graph so that masking and all that great UI stuff will just work automatically out of the gate. So we are making a circle, so let's add a radius property. And now we'll create our custom function node. If you've never used this before, what we'll do is reference our function here. I would never recommend doing a string here. It's just too painful to use. And we're going to grab our circle SDF function. Don't include the underscore float. That's the precision that we want. If you wanted half instead of float, then you would do underscore half, but we do want a float here. And now we just match the inputs and outputs. The names do not have to match when you use an HLSL file, just the types. So we have a vector 2 for our UV and a float for our radius. And our output is our distance. All right, so if we preview that, right now it's nothing because we want to plug in our radius as well as our UVs centered. And by centered, I mean we want 0, 0 to be in the center, not in the lower left, which means that we have to actually subtract 0.5 on the X and the Y to center our UVs. Now, when you plug that in, we have a black circle, which we can control with our radius parameter. And maybe even from here, you can see where this is going. If you know anything about shaders, you'd know that, okay, we could negate this so that the circle is white and then plug that into a step node. And now we have a nice white circle. However, with this method, if you zoom in, it's quite pixelated, which we do not want. So here is a trick to fix that. If you plug the negate node into a smooth step, and then take the DDXY of our circle SDF and plug that into edge 2, that's going to give us perfect anti-aliasing. So we already have a perfectly clean circle that we can control the size of. And we should definitely create a color for our shape. And multiply that. And if we plug this into the base color and this into the alpha, we now have a nice clean circle that we can change the size of, which I realize it's not all that exciting yet. But now that we have this set up, it's really not too hard to add some additional functionality to it. So let's take it a step further. Using SDFs, you can create perfect outlines as well. None of this 4 different texture samples or 8 if you want to get fancy nonsense. This is a true perfect outline. And just to make it easy, we're going to add that function to our HLSL file. It'll take in a distance, a thickness, and it will output a float. And all that we're going to do is take the absolute value of the distance and subtract the thickness from it. So back in shadergraph, let's create an outline color variable, as well as an outline thickness float. And now we're going to make another custom function node. It was called outline SDF. And again, it takes in a distance float and a thickness float, and it outputs another float. And we'll do the exact same thing that we did with the circle itself. So we'll negate it and plug it into a DDXY and plug those into a smooth step node. Now for the alpha, we need to incorporate this so it's included as a part of the shape. So let's disconnect these and we'll add these together. And even though this looks fine, we're going to plug the result into a saturate node because the white plus the white in certain spots gives us a value above 1, which we do not want. So saturate will clamp that for us. And we can plug that in. Okay, so now we want just the outline value. So to get that, we need to subtract the original shape from the outline. And we'll saturate this as well to clamp it. Now that we just have the outline, we can multiply that by its own color. And then finally add the 2 colors together and plug that into our base color. And there you go. Notice the thickness of the outline doesn't change regardless of the size of the circle, which is really awesome. Now again, I mentioned that the outline is always rounded, but this is a circle, so it's impossible to tell. So to show you what I mean, let's add another shape to our tool here. Here is the HLSL code for a simple rectangle. This is going to let us configure the size. And as per the usual with any SDF shape, we're going to take in a UV and output a distance float. So to add another shape option, we're going to add an enum keyword to our shader. We can get rid of C and just rename A to circle and B to rectangle. All right, so watch how easy it is to add in another shape. We're going to move our shape enum in there. If we want to draw a circle, then our circle SDF goes there and just replace all of the connections that we have with the enum output. And now if it's a rectangle, we'll just enter our rectangle SDF custom function. We take in a UV vector 2 and a size vector 2 and output a float called distance. We plug in our UVs and create a size property for the rectangle. And plug that output into the rectangle input on the enum. Okay, so we have a circle, and if we change our shape to a rectangle, there you go. The outline still works regardless of what shape we use. You can use any shape you want, this outline will work. And like I said, it's rounded on the corners, and this is a rectangle, so hopefully that's a little bit easier to see now. I think that is really, really cool. However, maybe you want a sharp outline that's not rounded. So if we want to do that, we could add what's called an inline instead of an outline. So let's create that. Let's open up our HLSL file and add this function, which takes in a distance, a thickness, and it outputs a float as well. And this is just the max of distance and negative distance minus our thickness. So we'll add that in. As well as a new inline color property and an inline thickness property. Distance comes from the enum. We'll plug in our thickness, and same thing again with the negate, the DDXY, and the smooth step. You could turn this into a subgraph so you don't have to do it every time, which would clean things up a little bit. I just don't like doing that because then you lose the ability to preview what you're doing along the way. So we'll multiply this by our color. So the only thing that we have to change is that this inline, it's like an outline, except it doesn't actually increase the size of our shape at all. It takes away from the main shape instead. So with that being said, from our main shape, we need to subtract out the inline. And we'll saturate it just to be safe. And plug that now smaller circle into our main color here. We don't actually need to change anything with the alpha calculation because the outline plus the main shape already equals the full size. The inline doesn't actually change anything with the alpha. And now we can just add the inline amount to all the other colors and then use that total as our base color. So now we have our main shape that we can change. And if you don't want rounded edges, you can add an inline or you can just do both. And it translates to both shapes just fine. Now, the beauty of most SDF shapes is that they are more configurable than what we have here. And this rectangle that we have is a little bit boring. So we can replace the HLSL of the basic rectangle with this slightly more complicated one that gives us full corner rounding control. Now that we've updated our HLSL code, we'll have to update our custom function node. And we'll want to create and pass in our new properties that we'll need as well. And now we can change each individual corner or all of them at once. So I do want to show you intersection operations, and they are a little bit trickier without a beefier system in place because each distance field needs to know about the other distance fields, which means that you're going to be drawing multiple shapes within one shader. So first we need to give ourselves the ability to actually draw more than one shape and move each of them around individually. And to do that easily, what we're going to do is in our UV calculation over here, we'll plug a shape1 POS into a subtract node and plug in the output of our original UVs. And now that is going to be our UV. So with that in place, you can see that we are able to move it around now. Now to draw a second shape, we can literally take all of this and just duplicate it and just make sure that we're plugging in shape 2 POS here so that we can move each of the shapes around individually. Now we need to combine the final colors and the final alphas of both the shapes, and we can do that by just adding them together. And then plug that into the fragment. Okay, so with that done, you can see we've got two different shapes that we can move around individually. But right now, if they overlap, since we're just adding the values together, you get this kind of washed out, brighter overlap here. So we're going to fix that by giving ourselves true intersection operations. So for a union, it's very simple. All we need to do is plug in a minimum node right here. We want to find the minimum distance value between shape 1 and shape 2. And whatever that result is, we'll replace all our distance connections on both shapes with that result. And I think this is literally the coolest thing ever. Now, when they overlap, they act as if they're just one shape. You can change the radius, the outline thickness, the inline thickness, and it all just works perfectly as if it was one shape. Now, I also want to show you intersection and difference and smoothing, and this video is already too long, so we're just going to do all of them at once. So we'll add 3 more tiny functions to our HLSL file. We're going to add in smooth union, smooth intersection, and smooth difference. You already saw what union does. This is just going to give us the option to smoothly blend the union, which looks really nice. It's very satisfying. What intersection is going to do is it's only going to draw the shapes where both of the shapes actually overlap each other. And what difference will do is it's going to draw one of the shapes and the other shape is going to subtract away from the first shape where they are intersecting. I actually find difference to be one of the most useful operations if you're looking to create really interesting and unique shapes. So we're going to get rid of our minimum node here and we'll replace it with another enum. This is going to be a combine operation enum. And let's also add in a smoothing factor float. All right, so we need to create our 3 custom function nodes. All 3 of them are going to have the same parameters. They all take in a distance A, which is the distance from shape 1, distance B, which is the distance from shape 2, and smoothing as well. And they all output a float, which is our new distance value. So the output of shape 1 goes into the distance A for all 3. The output of shape 2 goes into distance B for all 3. And we'll plug in smoothing for all of those functions as well. And now each one of those outputs just plugs into its respective enum value. And that is where all our connections go now. For both shapes, we're going to replace all of the connections that our minimum node was connected to before. And there you go. With union with no smoothing, you can see it's acting just like it was before, but I'll move them apart a little bit and slowly increase the smoothing, and they kind of get like attracted towards one another. It's really cool. Intersection, again, it only draws where they are actually touching. So if they're not touching at all, then nothing gets drawn. And difference, you could make, with 2 circles, a moon or something like that. And smoothing is interesting here because it kind of rounds the corners a little bit. So if you are looking for more SDF functions, I would highly recommend looking at Inigo Quiles's blog. I really hope I'm saying his name right. I'm probably not, but the website is linked down below in the description. He has so many formulas there. He shows you how you can round them. He shows you how you can make them annular. And he has a whole article on 3D SDFs as well. Now, all the code on his blog is using GLSL, not HLSL, so some of them are harder to port over than others. But yeah, all the info that you could possibly want to learn about SDFs is over there. Now, I have actually gone down a really deep rabbit hole with this. I was working on an upgrade system for my game Surgebound, and I just got so frustrated and so sick of looking at really ugly placeholder UI, and I just wanted a system to handle it for me, so I built one using SDFs. It has like 22 shapes or something. I went a little bit nuts. And it comes in as its own separate game object, so you can move it around and rotate it nicely. And it becomes really powerful when you can create SDF groups, because you could create some unique shape by combining two shapes together and then do it again in a second SDF group. And now you can use each of those as their own separate object to then further combine them together in some unique way. I had fun adding in just a whole bunch of options to give myself a lot of artistic control. The colors blend really nicely together. And you can just use this system in your UI if you want, but if you want to just use your unique shape and save it as a texture, you can do that as well. And again, because these are SDFs, you can save at basically any resolution you want. So if you would like this system for your game to help you build UI, it's available to my patrons right now. So if you want to help support the channel and get the system for yourself, then you can head on over to Patreon. Thank you so much for watching, guys, and I will see you in the next one.